In this video, we will review diffuse or generalized slowing or disruption of the background, as well as periodic discharges. Diffuse or generalized slowing and attenuation is often arbitrarily graded as mild, moderate, or severe. However, there are no standardized grading systems to determine these degrees of severity. Rather, each encephalographer uses his or her own internal criteria to determine the severity of the disruption of the background rhythm. Some indicators of severity of dysfunction include the frequency. Is it predominantly theta or predominantly delta frequency? The organization. Is there an anterior or posterior gradient? And are there other indications of normal organization of the background rhythm? Is the background continuous? And is there reactivity? Diffuse slowing, like focal slowing, can also be rhythmic or polymorphic. We will review several examples of diffuse background slowing and attenuation in order for you to get an appreciation of the range of diffuse abnormalities and how they relate to clinical disease. Here is an example of generalized or diffuse slowing. Taking the same approach as with focal abnormalities, if we compare the left side of the head to the right, we can see that there is no significant difference in the amount of theta, delta, or alpha activity on one side compared to the other. There is a bit more muscle artifact on the right side compared to the left, but that can fluctuate from time to time and can be asymmetric in any given patient. It may be helpful to demonstrate this recording on one side of the screen and a segment of normal EEG on the other side of the screen. Let's look at some of the things that show us that this is diffuse slowing. As opposed to the normal alpha activity seen here in normal wakefulness, which is maximal in the posterior head regions, we see diffuse theta and some delta activity, which is approximately the same on the front of the head as opposed to the back. In addition, the dominant background frequency is theta, perhaps best seen in these regions and these regions, in the range of approximately 4 to 6 Hertz. Compare this to the normal EEG, where the predominant frequency is in the 10 to 12 Hertz range, seen best in the posterior aspect of the head. Therefore, we would say that this patient likely has mild to moderate diffuse cerebral dysfunction, manifesting as mild to moderate diffuse slowing of brain activity on EEG. There are several indications of increasing diffuse cerebral dysfunction. Here we have a recording where the predominant background frequency is in the delta range at 1 or 1.5 Hertz, as opposed to the previous patient who had background frequency with both delta and theta activity. This might suggest a more severe variant of diffuse, nonspecific cerebral dysfunction. As encephalopathy or cerebral dysfunction progresses, the background can become discontinuous, as seen here. We have bursts of cerebral activity with mixed frequencies, including delta, theta, and alpha frequency, alternating with periods of diffuse background flattening or suppression. We would call this a discontinuous or burst suppression pattern. This pattern again is nonspecific and can indicate severe underlying brain dysfunction, although this pattern can also be induced with high doses of sedating medications. On the most severe end, you see diffuse attenuation. Here we have virtually no identifiable background brain activity, despite the fact that our sensitivity is at 5 microvolts per millimeter. Very low background activity might not be able to be picked up with routine EEG recordings, but we can say that this is at least diffusely attenuated, if not isoelectric. Again, this can be seen with severe brain dysfunction, but can also be seen after the administration of high doses of sedating medications. Diffuse attenuation can also be seen temporarily in the postictal period, especially after generalized seizures. There are several different types of periodic discharges. There are generalized periodic discharges, which involve both hemispheres simultaneously. There are lateralized periodic discharges, which are also known as periodic lateralized epileptiform discharges or PLEDs. And there are bilateral independent periodic discharges, also known as bilateral independent periodic lateralized epileptiform discharges or BIPLEDs. We will review examples of all three of these types of periodic discharges, and we'll also review the relationship between these discharges and clinical disease. Here is an example of generalized periodic discharges. You can see that there are regular, sharply contoured discharges occurring approximately once a second. They are maximal in the frontal regions bilaterally. If we look very carefully at some of these discharges, we can see that they have a very characteristic morphology. For example, if we look at this discharge in the F4C4 channel, we can see that there is an initial negative deflection, followed by a very large, broad, positive deflection, followed by a third lower voltage but still broad negative deflection. We would call these generalized periodic discharges with a triphasic morphology because of these three phases. Traditionally, these would be known as triphasic waves, which were often seen in metabolic encephalopathy, such as renal or hepatic encephalopathy. However, we know that generalized periodic discharges are a nonspecific finding and can be associated both with encephalopathy and with a predisposition towards seizures. Here is another example of generalized periodic discharges. You can see that on the left half of the page, for the first several seconds, there are no clear generalized discharges. Then the discharges appear on the second half of the page. Again, they are sharply contoured, have a triphasic morphology, and occur at approximately 1 discharge per second, or 1 Hertz. What we also notice is in the second half of the page there is some increased muscle artifact in the temporal chains. This likely means that this patient has been stimulated or is undergoing an arousal. Therefore, we would say that these could be stimulus-induced discharges, which is a common finding in encephalopathic patients. Here is another example of generalized periodic discharges, just to give you a sense of the broad range of discharges that can be seen on EEG. Here, the background EEG is diffusely suppressed with minimal activity in between these discharges. The discharges themselves are very high voltage and very sharply contoured. In this particular scenario, this patient has had a cardiac arrest and has developed diffuse cerebral dysfunction, expressed as the diffuse suppression of background activity, and also has diffuse cortical irritability, expressed in the high voltage, sharply contoured generalized periodic discharges. For the sake of contrast, I will show another example of generalized periodic discharges. These discharges are difficult to see until I point them out. Again, they are 1 Hertz, but they are much less sharply contoured and significantly lower voltage. In fact, they barely stand out from the background. This might suggest that this patient has a diffuse encephalopathy with some predisposition towards cortical irritability. The exact clinical significance of generalized periodic discharges is unclear and most likely depends strongly on the underlying clinical scenario. This is an example of lateralized periodic discharges, also known as LPDs, or periodic lateralized epileptiform discharges, or PLEDs. Again, we are in an anterior-posterior bipolar montage with left-sided electrodes on the top, midline electrodes in the middle, and right-sided electrodes on the bottom. Here you can see that there's a clear distinction between the left and the right sides of the head. On the left side, there are sharply contoured, complex, high-voltage discharges occurring approximately every second or two in a very periodic or regular pattern. To some extent, these discharges have a broad field that extends into the right hemisphere, but they are clearly maximal on the left. Lateralized periodic discharges indicate significant focal cortical hyperexcitability on the side or in the location of their maximal activity, and there is a strong association between lateralized periodic discharges and subsequent seizures on prolonged recording. Therefore, when these discharges are seen, additional recording should be done to ensure that the patient does not develop non-convulsive seizures. There are a number of etiologies that can cause lateralized periodic discharges, and they are relatively nonspecific. They can be seen after acute stroke, which is likely the most common cause. They can also be seen in infectious encephalitis, such as in herpes simplex encephalitis, and they can be seen in patients with known underlying epilepsy who have developed status epilepticus or recurrent frequent seizures. If we scroll forward in this patient, we can see how these lateralized periodic discharges evolve. On this page, we see the lateralized periodic discharges for the first few seconds. And then we see that the discharges become closer together. Gradually, you see very rhythmic activity emerging, maximal in the posterior parts of the head on the left. You can see that this becomes extremely rhythmic by the end of the page. If we move forward 1 page, we see that we have rhythmic activity, which is gradually becoming higher voltage, is evolving in complexity, and this represents an electrographic seizure. Moving forward, we see that this seizure evolves. On the first part of the page, the frequency of the seizure is relatively high. in the high theta or low alpha range. Later, near the end of the page, we can see that the frequency slows down to the low theta or delta range. Gradually, as we move forward, there are changes in the morphology, frequency, and amplitude of this rhythm. The rhythm becomes lower frequency but higher voltage, continues to slow in terms of frequency, and then gradually stops. At the end of the seizure, we see that there is a re-emergence of the lateralized periodic discharges. Again, one of the most important considerations is that when you see lateralized periodic discharges, you should continue to record the patient to ensure that they do not develop electrographic seizures. We will look at one more relatively rare periodic pattern. Here, if we look at the left side only, you can see that there are discharges that appear periodically, every second or half or so, maximal in the back of the head, highlighted here in red. Now, if we look at the right side, we can see that there are also periodic discharges in the back of the head, highlighted in blue, but these do not line up at all with the periodic discharges on the left. This pattern is known as bilateral independent periodic discharges, or bilateral independent PLEDs. This pattern suggests both cortical hyperexcitability or irritability and significant cerebral dysfunction to the point that there is a disconnection between this activity on one side compared to the other. BiPLEDs or BiPDs are uncommon but generally indicate severe cerebral dysfunction and, depending on the etiology, can be associated with a very poor neurological prognosis. In this video, I have provided an introduction to diffuse slowing and periodic discharges. As you can see, there is a broad range of expressions of both of these types of abnormalities, and I encourage you to continue reading EEG to get a full sense of the broad range of abnormalities that can be seen.